How does the water table affect groundwater recharge? Have you ever wondered how the water table influences the process of groundwater recharge? It's a fascinating topic that connects the dots between precipitation, soil, and our underground water systems. Let's break it down. The water table is the upper surface of the saturated zone in the ground. This is where all the tiny spaces in soil and rock are filled with water. Groundwater recharge happens when water from rain or other sources seeps down through the soil until it reaches this water table. This process replenishes the groundwater stored in aquifers. First off, recharge occurs right at the water table surface. When water infiltrates from above, it moves through the unsaturated zone until it hits the water table. This is where the water accumulates and adds to the groundwater storage. Next, fluctuations in the water table level can tell us a lot about recharge rates. After it rains or when irrigation occurs, the water table rises as new water enters the aquifer. The timing and size of these changes can indicate how much recharge is happening, especially in areas with shallow water tables. Another important factor is specific yield. This term refers to the amount of water that drains from the saturated zone due to gravity after the soil is fully saturated. It determines how much of the water that seeps in gets stored as groundwater when the water table rises. Aquifers with a higher specific yield can hold more recharge water, which affects how quickly and how much groundwater is replenished. The depth to the water table also plays a role in how efficiently recharge happens. A shallow water table means water has a shorter distance to travel through the unsaturated zone, which can speed up recharge rates. On the other hand, a deeper water table requires water to move through more soil, which can slow down the process due to factors like soil properties and evaporation. Finally, the interaction between surface water and vegetation is key. Groundwater recharge is linked to processes like evapotranspiration, where plants releases water into the atmosphere. This can either take water away from the saturated zone or redistribute it, affecting the overall recharge. Understanding how the water table influences recharge is essential for managing groundwater resources wisely. It helps in designing systems for artificial recharge and predicting how aquifers respond to changes in climate. Monitoring the water table can provide a measurable way to estimate recharge rates and assess the health of aquifers. So, the water table is not just a boundary. It's a vital part of how groundwater recharge works, influencing everything from the amount of water stored underground to how quickly it can be replenished.